So, hello everyone. My name is João Pedro. I'm from PION, and I'll be presenting to you a little bit about our project, PION BR1 Satellite. And as you might have noticed for the title, by the title, what we learned through all the experience of doing the first satellite of many that we propose. So the title is "How Not to Build a PocketQube" or "How Not to Build an orbital class PocketQube." Much like some space company did a video of their failures, we'd like to point out some of our failures so you can improve yourself and you can make better pocket cubes in the future. So let's go. So PION's history. We have a history of some dedication and resilience here. We were founded in December of 2019. We are a Brazilian space startup, and we are right now Latin America's largest small educational satellite kits provider. We have a contract with Brazilian government, and we supplied for the government over something around 300 satellite kits for the Brazilian Satellite Olympiad. And we are promoting here in Latin America space STEM activities. We have, for example, the Latin American Space Challenge, where we were a huge tournament around launching rockets and designing satellites and a lot of other different things. And the PION BR1 team is, of course, a small but mighty team. We're a small team of 4 people directly related to the project, and PION has more people on other projects as well. And on this team, we have aerospace, mechanical, and electronics engineers. We've combined more than 10 years experience with space and electronics related fields. So have experience in model rocketry, hybrid rocket motors, robotics tournaments, rocketry tournaments, and organization and participation in those as well. And who am I? I'm João Pedro. I'm currently CTO and technology manager at PION. I'm maybe a little bit on the younger side here. I'm a 24-year-old, and I'm a robotics and automation engineer. And I'm really passionate about problem solving by making things, especially if they involve electronics, programming, and 3D printing. So I started building robots and circuits as a 10-year-old and made my first circuit boards a few years later and never stopped working with electronics and really doing my problem solving using all these tools and everything. So what is PION BR1? It's the first Brazilian non-governmental related satellite. It's a 1P pocket cube proposed to pioneer the private space access in Brazil. And it is really the first satellite developed by a Brazilian startup that will be launched into orbit. And it is really a test bed for us for the communication systems, the attitude control systems that we are trying, the solar power harvesting, and for making really space-ready systems in this small form factor and with cheap enough hardware. The platform that is a platform that will allow radio amateurs and schools to close the gap between space communications and the general public. So, yeah, we'll be trying a lot of different things. And this is probably the first of many satellites, PION BR1, PION BR2. We are really starting now. So what to do? Here we are going to do to give you some advice from our team. And this advice is something that we thought like, oh, what is really some information, some advice that we will benefit from having like a year ago or so. So we are here to first remember the KISS method, right? I don't know if you are familiar with it, but it's the keep it simple, stupid method. I hope I'm not really offending someone, but this is a keep it simple, stupid method, something we could really have put our minds into here, and it would have saved us a lot of time. And then if you remember the keep it simple method, you may use it. So do not use like us some overly complex internal architecture with a lot of different microcontrollers and intercommunication. So we have some boards inside the PION BR1, and we really went to town on the microcontrollers and a lot of different communications link. We have a serial between microcontrollers of different parts and different microcontroller part numbers. And for that, we had to develop a data protocol that had to be robust to resist the space environment. And everything will take a lot of time, and this will take a lot of time to develop and to get it right. So yeah, mind your use of your controllers and really try to keep it simple. What more? search for suppliers everywhere. Just remember to test it. And of course, use your testing 3D card for collision, right? We had some problems, and I think everyone is having some problems around the component charges. So our advice would be for you to minimize your BOM and size. Yeah, minimize your BOM size and comply with the keep it simple mindset, right? So you do not want to have like 3-4 microcontrollers on your small satellite. So you have to make your BOM smaller, and you may need to buy more than needed, because if you need some later, they might not be available. Like on this picture here, Mauser is 0 in stock, 𝗖𝐶 0 in stock, DigiKey 0 in stock. And then PION went to town with Alibaba, and we had really some great partners there at Alibaba, and we just tested a lot what they sent us to make sure that they sent us great things and not like some copies or fake hardware. And an advice on how to test everything if you don't have the hardware yet. Well, you have to remember CAD tools are here to help you integrate the satellite and build everything. And remember to model every component up to a single capacitor and prevent some of the mistakes like this one up here, where we didn't model the capacitor in the board, only the major components, and ended up having a small collision of the capacitor there with a spacer. And also, do not trust your supplier of uncharacterized communications module. This is really great. And of course, do not trust some suppliers for a simple switch. They can mess it up. For example, if you're using COTS communications modules, that is commercial off-the-shelf modules that are already ready-made, they will save you some development time. But do not trust the datasheets. They will definitely be more power hungry than they say, or their datasheet will miss some important information. So yeah, something that we realized then as well was, do not trust the suppliers for even a simple switch, right? We saw this difference. I think you're seeing it with these pictures that we took. And we bought a lot of these switches preparing for component shortage. We went like, oh, let's buy 50 of each or something like that, just to be on the safer side. And then we realized they were different lead sizes. Even though they were Omron brand switches, they had some small differences, maybe from their fabrication lot or something like that. So yeah, and about testing, your satellite is complex, but your testing doesn't need to be. Talk to your suppliers and contractors. A simple talk could find better solutions or even some cost savings. So by talking to our vibration test provider, our mechanical engineer found an opportunity to use cheap 3D printed fixturing instead of like CNC aluminum jigs, and he really exchanged some information with the test provider, and they said, oh, we can test now, and if it's working, and if it doesn't disassembly on itself, doesn't do something funny, we can definitely use it for your qualification test. And we just went there, took some mechanical prototypes of the satellite and our 3D printed test jig, and tested it. So it's here on the right. It's really vibing, and you may not see it because of, I don't know, some things. And some great advices we can also tell you, and is the really what we use a lot here at PION is the fail fast, succeed faster methodology. And yes, learn from your past experiences. And we say a lot that if you're not failing, you're not innovating enough. And we made a small joke here. There's a cloud of words that is the most cited as an advice from PocketQube project engineers. And from this survey here, I don't know the source, but out of 10 advices, 11 are about testing on the PocketQube community. So test as much as you can, or yeah, fail fast to succeed faster, and learn from others. Yeah, this is basic advice, but there are many examples of failures that have similar root causes in the satellite sector. I read, for example, at the beginning of the project, the failures about the crackset projects and another project documentation online, and this really helped us to focus our work on some areas, and on other areas we decided to let go of the things we were planning because they would be more difficult to approach or something around that. And plan your development cycles and follow your plans. And remember that unplanned situations happen along the way. So you have to plan for these situations as well. So plan ahead. And about frequency coordination, this was something that we really learned a lot as a small team that had no prior experience or previous experience with really frequency coordination and RF frequency. So it's not simple to coordinate a frequency for your satellite. You first have to check where is your satellite's mission. If it's a commercial mission, meaning you will have revenue from it, or if it's just a tech demonstration for your company, this is might be a non-commercial mission. But even like this, we will need a specific commercial frequency. Only if you are preparing an amateur mission, there is an amateur service, and that will contribute to the radio amateur community, then you can coordinate with 𝗖𝘀, amateur radio union, for an amateur frequency, right? So yeah, if you want to do the amateur way, yeah, just an open telemetry. We are going to be sending telemetry from our satellite. It's not an excuse for the amateur satellite service. You really have to contribute something to the amateur radio community to use the 𝗖𝘀 provided and coordinated frequency. And submit your request for the 𝗖𝘀, and then you have to submit your ITU, your frequency coordination request, and a lot of other things. So this is really some great advice for you to keep in mind, that you may have to pay the fees or not. It depends on your satellite's mission. There is something that we really need to get from the first time, right? So yeah, signing a launch service agreement. What your expectations could be like: contact Alba, book the launch, sign an LSA, launch your satellite. And what we really you really should expect of doing is brainstorm your space mission, develop your systems and subsystems, manufacture your systems and your structure, assemble your prototype, extensively test that prototype, optimize and adjust your satellite project, and then contact Alba for launch dates, sign a memorandum of understanding, then start your frequency coordination, manufacture satellite flight model, sign the launch service agreement, and submit frequency coordination documents and final tests and bake out of the flight model. And then you deliver your satellite to Alba Orbital. And of course, as we like rockets, watch your satellite being launched. So we really like for you to follow this this path, because yeah, the path on the left has less steps and less planning. So you should really be planning more, a lot of different things about your satellite. And because satellites are also complex, the only because they're small, they are not complex. Yeah, from this Brazilian expression, the size is not a document. So yeah, size doesn't matter, right? A satellite is a satellite regardless of its size and dimension. And satellites are complex. Their mission concept, the design, the development, the manufacture, the assembly, the test campaign, certification, qualification, the logistics of everything, the integration to the launch vehicle, everything. And really, from like 11,000 kilograms to 0.25 kilograms to 150 grams, and from the research of space to and then radio material and educational mission, everything is really is really at the same part. Is really at the same way. We have systems engineering concepts, we have project management and milestones, and they're similar for every kind of satellite. So yeah, even the Hubble Space Telescope, that is the same size as the PION Labs Happy Birth here, and the PION BR1 satellite, they share a lot of different things, and the PION BR1 satellite is a great tool. Was a great tool for us to really experience this concepts of systems engineering and really the concept of everything around developing a satellite. So yeah, thank you everyone. That was a little bit on the funnier side, because we like as well to laugh from our mistakes and to share with others so they don't make the same mistakes as we did. And if you want to contact us, if you want to contact me, you can reach us at PION Labs at Facebook or at Instagram, or maybe send us an email at liftoff@PION Labs, or at my email if you want to contact me. It's joaopedro@pionlabs.com.br. So yeah, that's it.